In early 1995, Europe was swamped by torrential rain. Large areas of Holland, including whole cities, were flooded. As people worked round the clock to save their homes, they were repeating a struggle that humans have fought countless times before. Just 3 years earlier, the massive Mississippi broke its banks and brought the worst flood in the United States for 66 years. Giant floods like this do enormous damage. Lives are lost and homes are ruined. But the worst of all floods arrive with no warning. This is Big Thompson Canyon, 50 miles northwest of Denver, Colorado. On Saturday, July the 31st, 1976, the state of Colorado was celebrating its 100th anniversary with a long weekend. Thunderstorms were forecast for late afternoon, but no one was prepared for what was to come. Country musician Jerry Schaefer lived in the canyon.
It was a really overcast, kind of, but it wasn't raining here. I noticed that, there were clouds out, and we were out mowing grass that day and working on the cars and things. But I also did notice that if you looked up the canyon up there, there was really dark, dark thunderstorms, just like the whole mountainside.
In mid-afternoon, a camper walking in the Rockies above the head of the canyon took this photo of an extraordinary thundercloud that had been growing all day. By now, there were 3,000 people scattered throughout the canyon. At 6 p.m., the cloud erupted into a thunderstorm. Over the next 4 hours, the storm poured 10 inches of rain onto the ground below. An incredible amount compared to the usual annual rainfall of only 14 inches. The conditions were perfect for a flash flood. The steep rocky slopes absorbed very little water. It was quickly funneled into the canyon below. The river started to rise. Glenn Floyd owned a motel in the canyon.
Pretty soon, around the bend, here came this wall of water. Nobody could believe what was coming next. In a matter of about 5 minutes, it came up so high, it took my bridge out, and another 5 minutes, and the cafe and the home and everything went.
Further down the canyon, Jerry was caught in the flood with his friend Eli.
We didn't know it at the time, but the dam had busted up above us, and that whole 19-foot wall of water was coming right at us. When it hit, it forced me over, and I had it in my arms, and what had happened, that whole mass of water and debris was skimming over the river. So we were in the river part, and every time I tried to raise up, that would mash me back down. And Eli went limp in my arms. I don't know if he drowned or had a heart attack, but I knew he was gone, and I was starting to see stars. I looked up. A large, giant white wall, a barn, was coming at me at 70 miles an hour. Hit the trees just as I threw the mattresses over my head and exploded. What had happened then, it had formed a big delta of debris, and the rest of the night, the flood just went around me. And there I sat, thinking, this only happens in Reader's Digest. That was what I was thinking that night.
The rain continued to pour, and the waters raged through the night. Rescue workers went into action. Darkness made the search for survivors almost impossible. At dawn, rescuers learned the full extent of the tragedy. The river had swept away everything in its path. Rescue helicopters continued to search the canyon. picking up a lucky few who had scrambled to higher ground. Over 400 houses were destroyed, and a further 138 damaged. Search teams found cars buried 6 feet beneath the bed of the river. In just a few hours, rain caused more than £16 million worth of damage. Worst of all, the flood killed 145 people, and 6 bodies were never found. Today, the only evidence of that flood is the warning signs. The destructive power of water lies in its weight. A large bathful weighs 3/4 of a ton, so it only takes 2 feet of water to wash a car away. 60% of the people killed in floods in the United States were trapped in their vehicles. To most of us, floods and rain are just a nuisance. Heavy showers disrupt our cities and make life miserable. Yet all life on land depends on rain. Without rain, our world would become a desert. The story of rain begins at the oceans. 3/4 of our planet is covered in water. This vast reservoir supplies most of our rain. Here, the sun beats down day after day. The seawater evaporates into an invisible gas, water vapor, which is carried by the wind high into the atmosphere. Waves, too, play their part. They throw tiny crystals of salt into the air. Other microscopic particles, like smoke from forest fires, also help to make rain. As the water vapor rises high into the atmosphere, it cools. Eventually it condenses onto the tiny particles, and a cloud is born. Water in the air is constantly changing between visible droplets and invisible water vapor, so the life of a cloud is often very short. The average cloud only lasts about 10 minutes. Yet all those water droplets add up. A typical cumulus cloud weighs over 500 tons. Inside a cloud, the droplets are tiny. They're so light that each one would take 16 hours to fall to Earth. It takes 1 million of these tiny droplets just to make 1 drop of rain. Rain starts at the top of the cloud as snow. It's so cold up there that the water vapor freezes into ice crystals. At the bottom of the cloud, where the air is warmer, the snow melts. Raindrops plummet to the ground. Measuring the size of a raindrop posed a challenge for early scientists. They came up with a simple recipe. Sift 1/2 pound of flour into a tray and leave in the rain for a few seconds. Next, bake in an oven for 20 minutes at 350 degrees. Finally, sift the flour again to reveal perfectly cooked raindrops you can measure. To count as rain, drops must pass the World Meteorological Organization's test. Only drops of 2/100ths of an inch or more qualify. Any smaller, and it's just drizzle. Drizzle tends to come from thin layers of cloud, like this stratus. Tall, towering clouds produce drops big enough to be called rain. The largest drops are formed in the tropics. Here, the sun's energy creates the tallest clouds and the most violent thunderstorms. The world's rainforests depend on heavy rain. This ecosystem has evolved to rely on regular torrential rain showers. Believe it or not, these people are sunbathing right by the rainiest spot in the world, on Kauai Island in Hawaii. Although it's sunny down here, high above the bathers on Mount Wa'ali'ali, it rains 360 days a year, more days than anywhere else in the world. The mountain creates its own rain. Winds bringing water vapor from the Pacific Ocean are forced up the steep slope of the volcano. The air cools as it rises, water vapor condenses, and it rains. Despite the rain, floods here are rare. The slopes of the volcano drain away most of the water. The rainforest and vegetation act like a sponge, soaking up the rest. Elsewhere in the world, the rain is less predictable. We rely on weather forecasts. The cold and warm fronts on weather charts show where it's likely to rain. Rain falls wherever moist air is forced to rise. This happens at a cold front. Here, cold air is chasing warm. The cold air is heavier than the warm air and slices underneath it like a wedge, forcing it upwards. The warm air cools as it rises, condenses into clouds, and it rains. The towering clouds of cold fronts bring heavy rain. A warm front is much gentler. At a warm front, warm air is advancing. When it hits the cold air, it slowly slides up and over it, forming a thin layer of cloud. This grey blanket of stratus cloud is the sign of an approaching warm front. It brings a long period of steady, light rain. When the air is dry, rain can evaporate before it reaches the ground. The rim of the Grand Canyon receives 16 inches of rain each year. 5,000 feet below, at the foot of the canyon, only 6 inches hits the ground. The other 10 inches evaporates on its way down. These trails of rain that evaporate as they fall are called virga. Rain is just one stage in the life cycle of water. After a shower, the rain drains through the soil. It bubbles out again as streams. The streams become rivers, winding their way towards the ocean. The rain returns to the sea to begin life again. But sometimes, even the largest rivers can't handle the rain. Over 100,000 streams drain into the Mississippi. It collects rain from 2 Canadian provinces and 31 American states. At the River Forecast Center in St. Louis, they monitor the level of the Mississippi on the lookout for floods. In early 1993, an exceptional amount of rain fell in the basin around the city. By spring, the ground was saturated, and the reservoirs upstream were overflowing. The River Forecast Center went on alert. The weather radar showed a lineup of storms heading their way. The river continued to rise.
The following is a flood potential outlook issued by the National Weather Service in St. Louis, Missouri. Heavy rainfall is possible again over the northern half of Missouri tonight and Friday. The ground is saturated and many rivers are near or above flood stage. The heavy rain will run off quickly and may produce flash flooding. People living in or traveling through northern and central Missouri should listen for the latest forecast.
Finally, the river burst its banks. The worst flood in the United States for 66 years had begun. Over 340 square miles of land was underwater. Hundreds of houses were destroyed and tens of thousands damaged. The cost was enormous. Despite the extensive destruction, the flood warnings prepared many people. Most were able to leave their houses in time, but 50 people were still killed. We have built on the edge of rivers since earliest times. The fertile land and steady flow of fresh water make this a natural place to live. But the devastation caused by the Mississippi forced the people here to rethink. In August 1993, the Mississippi flooded the town of Valmeyer. It was underwater for 2 months. A year later, Valmeyer had become a ghost town. The citizens decided that enough was enough. They're rebuilding the town on higher ground, away from the threat of more floods. Jim Smith is in charge of the project.
We're approximately 200 feet higher than the area of flooding from last year. So it's up in a good elevation, good and safe. The 100-year flood record and information shows it will never flood here, so the people have chosen a location that's out of the flood danger.
The people of Valmeyer may not think so, but in some ways they are lucky. Millions of people in poorer countries have no choice but to live on the rich floodplains that supply their food. Seen from space, giant storm clouds gather over Bangladesh. They are bringing the monsoon. For 6 months every year, wind in Asia blows from the land to the sea. The climate is dry. Now in June, the land in Central Asia heats up and the winds change direction. Air is drawn in from the sea. and these moist winds bring the monsoon. This is the monsoon season, 6 months of torrential rain. The people of India and Bangladesh rely on the monsoon. The rain softens the soil, and they can now plant the rice crop. But sometimes the monsoon rains are too much for the streams and rivers. In 1970, floods in Bangladesh killed 500,000 people. When this water subsides, the survivors will have to go back and live on the floodplain. But they know it'll only be a matter of time before the rain comes again. Rain affects each and every one of us. It doesn't respect culture or society. It can destroy by brute force. Yet what takes life gives life.
Of planet Earth, and the possibility that there might be other similar worlds. The overwhelming power of a river in full flow, and the menace of a tropical storm. The open spaces of a hot savanna, and the freedom of natural flight. The eternal search for answers about the origin of mankind. Our fascination with the stars. The awesome products of human ingenuity that are all around us. The mystery of a UFO sighting. The unstoppable progress of science as it changes our lives. And the desire to learn from past mistakes. The knowledge that we are not the only species struggling to survive. The ability of a single person to influence the lives of millions. All of this and much more on Discovery Channel.
Snow. Delicate crystals of water. No two flakes are the same. It has carved whole new landscapes. And each year turns a quarter of our planet into a playground. A playground that is both beautiful and treacherous. "15,000 years ago, half the world was covered in snow and ice. This was the last great ice age. Glaciers a mile thick gouged huge valleys through mountains. All life beneath was annihilated. Even in today's warmer climate, snow and ice still cover the world with a beauty no other weather possesses. The storms which bring this beauty can be devastating. A single snowstorm can drop 40 million tons of snow. Even our largest cities are brought to a standstill. The world's polar regions are covered in permanent snow. But despite the intense cold, much of this vast snowland is home to native Indians. The Inuit of Baffin Island in northern Canada have built their homes out of snow for thousands of years. Snow is so much a part of their lives, they have over 40 different words for it, which means snow. A blizzard, snow goggles, an avalanche, and a snowflake. Snowflakes as big as 10 inches have been reported, but they begin life as tiny ice crystals. One of the first people to investigate them was Wilson Bentley. Starting in 1880, he spent his life photographing snowflakes through a microscope. He took over 5,500 pictures, and to his amazement, every one was different. Of all the snowflakes that have ever fallen, no two have been identical. The story of how snowflakes grow into this amazing range of patterns starts here, inside a cloud. The minute water droplets that make up the cloud freeze into ice. The molecules of water arrange themselves into hexagons, and as the ice crystal grows, it becomes a six-sided figure. At -1 degree Celsius, the ice crystals grow into thin plates. At -9 degrees, they form hollow columns. And at -15 degrees, they grow into everyone's idea of a classic snowflake. Each snow crystal is exposed to a huge variety of different air temperatures, so the patterns created are infinite. At -24 degrees Celsius, Charles Knight in Boulder, Colorado, has one of the coldest laboratories in the world. Here he selects and examines individual snowflakes. Despite what Wilson Bentley's old photographs would have us believe, most snowflakes are not symmetrical. Wilson Bentley only photographed the pretty ones. In fact, 99% of snowflakes are quite ugly. The snowflakes we know and love are actually clumps of snow crystals. When the temperature hovers around freezing, the crystals turn wet, stick together, and create the snowflakes you see falling from the sky. Measuring the amount of snow that's fallen from a storm is easy, Meteorologists simply use a ruler. But there's more to snow than depth. Weighing it reveals how much water it contains. Wet snow can be very heavy. Just a few inches on a flat roof can crush a building. The type of snow you get depends on where you live. In the dry air in the center of a continent, the snow is fine and powdery. Coastal areas produce wet, sticky snow, ideal for making snowballs and snowmen. Wet snow can also form snowballs spontaneously, without help from children. These are snow rollers. They can be up to a foot in diameter. A slight warming makes the top snow wet and sticky, and when a strong wind blows, it rolls the snow up like a carpet. In the bleak northern reaches of Canada, the Inuit work with dry snow. Shu is an Inuit hunter born 60 years ago in an igloo. These days, the Inuit use igloos mainly as hunting lodges rather than permanent homes, but the skills of igloo building are still alive. Shu is a master builder. The snow he uses comes from snowdrifts. It's packed hard together by the fierce Arctic winds. He lays the blocks of snow in a spiral to give the igloo strength. It takes just over an hour to build an igloo like this. When driven by gale-force winds, snow becomes a blizzard. The wind whips up snow from the ground, cutting visibility until everything appears white, a whiteout. People have been found frozen to death, lost in thick snow, right outside their own homes. If the snow is fine and powdery, it can cause a gruesome death, choking the lungs and suffocating its victims. Mix blizzards with traffic, and you have hell on wheels.
Another one?
While snowstorms bring traffic to a crunching halt, blizzards actually help the Inuit navigate. The snowdrifts point like a compass into the prevailing wind. The Inuit call them kimujuk. David Serkoak explains.
Kimujuk could be used for a direction by the hunter if the hunter happened to lose his bearing. Normally, a hunter would look at the formation and the archway, and these directions are normally from the north going on to south, and a smart hunter always knows his general direction and he can find his way home.
Beauty and grace of snow, it holds a fearsome power, just waiting to be unleashed. Avalanche. As it falls, it picks up more and more snow, as much as 1 million tons. Without friction to slow it down, it can reach up to 200 miles an hour. It drives an invisible wave of air which blasts out and smashes everything in its path. As snow sports become more popular, the number of casualties from avalanches is rising. Tim Auger's professional training as a mountain guide helped him survive.
If they're lucky, it's a small slide, and they can sometimes help themselves by trying to stay falling uphill and staying in an upright position and kind of cycling their arms to have the snow that's trying to move by and come over top of them. They try and keep it going underneath them, and then if the snow slows down, they're lucky. But if it's a bigger slide, they're in trouble. I ended up buried approximately 1.5 feet under the snow. I could not move a fraction of an inch. It was like I was totally encased. And even though it may have only been a short distance to the shallow depth, there's no way you're going to break out of the snow. As soon as the snow stops moving, you're locked in.
The energy inside the avalanche is so intense that much of its snow melts. Once the avalanche stops, it instantly freezes again. It's like being entombed in ice.
After only 15 or 20 minutes, the person or people who are completely buried in this snow, half of those people are already dead.
Ski resorts consider avalanches such a serious threat, they employ special avalanche squads to search out and destroy potential danger spots. Tom Riley is an avalanche forecaster. He's cutting through soft snow, feeling for a hard, icy layer. This is the weak point, a perfect surface for an avalanche to slide off. At crack of dawn, the avalanche patrol set off up the mountain. Their aim is to trigger an avalanche before the real thing takes place.
Step over, that's far enough, Ev. Fair enough. It's real cut back and then...
At the top of the mountain, they prepare to detonate the cornice, a vast overhang of snow.
We're putting explosives in the cornice that are all connected on a detonating cord called a trunk line, and we're going to drop that cornice onto the slope behind us, which we hope will cause an avalanche, and the whole slope will release and there will be no danger left on the slope below us. Fire in the whole north corner.
Target 22001. Sight range 1100.
The Kootenai Pass in British Columbia. On this 12-mile stretch of highway, there are 50 places where avalanches are frequent.
22001. Sight range 1100. Correct. Ready to load.
This truck will be the last through before the road is closed. Avalanches occur here so often that the authorities have set up a permanent gun to shoot off controlled slides.
Super quick, quick. Projectile's okay. Projectile's okay. Barrel and breech are clear. Loading. Full cock. Full cock.
All clear?
Each year, they fire up to 1,000 shells.
Fire!
To reach into the more inaccessible places that threaten the road, the team takes to the air.
Okay, let's move into the next target.
Leader John Tweedy does the snow bombing.
Okay, forward about 10 meters. Okay, hold. All right, we're on target, Phil. I don't want to take this out of bomb too far. Okay, fuse lit. Bombs away.
Over 20 feet of snow covers the road. If it hadn't been triggered artificially, this slide could have happened at any time. With the arrival of spring, the sun grows stronger. The snows melt away, and the avalanche is gone. On the mountaintops and polar regions, snow remains all year round. This world of permanent snow gives birth to colossal rivers of ice, glaciers. Year by year, the snow builds up, its weight compressing the layers below. Over hundreds or even thousands of years, the snow is compacted to solid ice. The ice at the bottom of this glacier in British Columbia fell as snow over 100 years ago. Mark Ludwig is a mountain guide. After years of leading climbers over this difficult terrain, he has come to understand the ever-changing landscape. Glaciers are dangerous. Each deep crevasse can be a death trap.
This is a Dauphine icefall, which is the edge of the Dauphine Glacier, and this is the part of the glacier which pours over a cliff, and here it drops down about 1,500 feet. And this is potentially quite a dangerous place because of these seracs, which are these big ice towers that we see around us, which are part of the icefall, and this is the part of the glacier which cleaves off and falls down into debris on the valley floor.
The summer thaw means glaciers here in the mid-latitudes are only hundreds of feet thick. This is thin compared to the glaciers in Antarctica. This, the greatest expanse of snow on Earth, covers 5 million square miles. The ice sheet here has been building up for thousands of years. It has grown into an ice cap 2 miles deep. At the edges, glaciers peel off into the ocean and break up into icebergs. Before it melts in the Arctic waters, the snow here provides one last service. The brilliant white of the ice sheets reflects most of the sun's heat. These Antarctic snows prevent our whole world from overheating. Exquisite, unique crystals of ice, so tiny they're hardly visible. This substance can be molded into snowballs or can carve the contours of the earth. One day, snow may once again fill these valleys and plunge our planet into the chilling cold of a new ice age.